Hello students. In this class we are going to discuss about the topic Fourier series. So what is the Fourier series? Fourier series is basically, as the name suggests itself, it is an infinite series in which we can represent a function in the form of a trigonometric function like the sine and cosine terms. So basically in many engineering problems like the conduction of heat, optics, electrodynamics, etc., where it is necessary to express the function in the form of sine and cosine term. So in that case, there we use the concept of Fourier series only. So Fourier series is a infinite series of the type a naught by 2, which is a constant term, plus a1 cos x plus b1 sin x plus a2 cos 2x plus b2 sin 2x and so on, where a1, a0, a1, b1, a2, b2, so on. These are constants, which are also called the Fourier coefficients. So Fourier series, it was introduced by Joseph Fourier. So basically the purpose was to solving the heat equation. And Fourier series is very useful for solving many boundary value and initial value problems, especially in case of ordinary and partial differential equation. So, so how can we express a function in the form of a Fourier series? So suppose that we have a function f of x, which is defined in the interval, say c to c plus 2l. So we want to express that function in the form of Fourier series. So what are the conditions that need to be satisfied by this function so that we can express that function in the form of Fourier series? So the conditions are: number one, your function should be periodic, single valued, and finite. Second, your function should have a finite number of point of discontinuities, should have at most finite number of point of discontinuity in any one of the period. Third one, f of x has at most finite number of maxima and minima in one of the period. So this is one of the important property of the Fourier series, that even if your function is discontinuous, we can express that function in the form of Fourier series irrespective of the other infinite series like the Taylor series expansion also. Okay, so when we'll solve the problem of the Fourier series, then the first thing is you realize that your function is like in this particular type. For example, your function is given as f of x equal to x in the interval 0 to 2 pi say. So what this interval represent? Obviously, you can see here your function f of x is x and f of x is equal to x in the interval 0 to 2 pi. If we plot the graph, then it look like this. So definitely it is not a periodic function, because periodic function means that a function which repeat itself, but it is not repeating, right? So basically the interval which is given here, it represent here one of the period of the function. Okay, so it means that before this interval and after this interval, the nature of the function is same. Like in the 0 to 2 pi, the nature of the function is like the function f of x equal to x, like a straight line. So from 2 pi to 4 pi, it will again repeat itself. And even before this function also, the nature of the function is like this. Okay, so that's the reason this function is a periodic, and it has a point of discontinuity. Like at the point 2 pi, it has, if I consider the open interval, and we get that it is a point of discontinuity because the function take a sudden jump. Okay, and of course it has a point of maxima and minima also at the end point. So it means that we can express this function in the form of Fourier series. Okay, so before we proceed with that one, so firstly we'll try to discuss some of the important properties which we need to know. The first one is, what is a periodic function? Like I discussed, periodic function means a function which repeat itself, right? So we can define it in this way, that a function is periodic if there exists a smallest positive number t such that f of x plus t is equal to f of x. So here t is called the period of the function f of x. For example, I can consider sine x. So we know that sine is a periodic function with period 2 pi, like sine of x plus 2 pi is equal to sine x. So also we know that sine of x plus 4 pi, right? Because uh, suppose that this is x-axis and this is y-axis. So here I am considering this is the first quadrant, this is the second quadrant, third quadrant, and this is the fourth quadrant, right? So here the value is 0, this is pi by 2, here the value is pi, here the value is 3 pi by 2, and here it is also 2 pi. So at x equal to 0 and x equal to 2 pi, the value of sine is same. Okay, and again, even if I consider one circle that is 2 pi, the value of the function repeat itself. Again, if I consider one more 2 pi, 4 pi, 6 pi, the value will remain same. So it means that sine of x plus 4 pi is also equal to sine x. But in this case, we can say that the period of the function is 2 pi. It is not 4 pi. Okay, because what is the period? Period is the smallest positive number t such that f of x plus t is equal to f of x. So in this case, I can also write it as sine of x plus 2n pi is equal to sine x, where n belongs to any integer. The value of sine will remain same. Okay, but the period of sine is 2 pi only. Similarly, in case of cosine function, the period of the function is 2 pi because cos of x plus 2 pi is cos x only. Okay, now next, before we start with the Fourier series, so we need to remember some of the important properties of integration. So it will gives us the condition of orthogonality also. That because we know that sine is a periodic function, so when we solve this, it is a simple definite integral problem. So when we solve this integral, you will realize that this value is 0. The reason is because when we substitute the upper limit and lower limit, it comes up with the same property of the type sine of 2 pi plus theta is equal to sine theta. So because sine is a periodic function, so in both the cases we get the same value. So on substituting upper limit and lower limit, you can get the same value. So its value comes out to be 0. So sine n pi x upon L in the interval c to c plus 2l, its value is 0 for all n belongs to integer. Same for the cosine function. And when we consider cos into sine, so here we can use the property of the trigonometric function that is 2 sine A cos B. This is equal to sine of A plus B plus sine of A minus B, right? So in this case, because what is A? A represent n pi x upon L and B represent n pi x upon L. So when we add them, m is an integer, n is an integer. So m plus n is also integer and m minus n is also integer. So because the integral of sine is 0 for every integral value of n, so that's the reason this integral is also 0 for any n and mp integral values. But in case of property number 4 and 5, there are two possibilities. Either its integral is 0 or its value is L. The reason is in case of 2 sine A sine B, so we can use the property sine A into sine B. So we can use here again the trigonometric identity, which is cos of A minus B minus cos of A plus B, right? So again, when we add or subtract, then n minus m and n plus m, they are integer. And we have this result that for any integral value of n, the value of this integral is 0. But this is the case when n is not equal to m. If n is equal to m, like if a is equal to b, then if a is equal to b, then cos a minus b is 1 because cos 0 is 1. And here we have cos of 2a. So cos 2a means again it is 2n because when n and m is same, then it is cos 2n. So cos integral multiple of pi, again its integration is 0. So this integral is 0. But this integral of 1 is upper limit minus lower limit. So its value is the length of the interval, that is 2l. Okay, in that case integral is 2l. But because we have multiply and divide by 2, so the value of the integral comes out to be L only. Okay. And the same case is for last case. So here, if we use the property 2 times cos A into cos B, then this is cos of A plus B plus cos of A minus B. So cos of A plus B plus cos of A minus B. So when we take the sum m plus n, again integer, its integral is 0. N minus m, again integration is 0. And when n is equal to m, then cos 0 is 1. So in that case, integral of 1 is 12, is the length of the interval divided by 2. So its value comes out to be L only, because the integral of cos 2a is 0, because cosine is a periodic function. Okay. So these are some of the important property of integration which we use while deriving the formula for the Fourier coefficients. Now let us come back to the part of Fourier series. So a function f of x, which is defined in the interval c2 c plus 2l, it can be expressed in the form of Fourier series, the form of Fourier series, in the form of Fourier series, that is f of x is equal to a naught by 2 plus summation n varies from 1 to infinity a n cos n pi x upon L plus bn sine of n pi x upon L, where a naught, an, and bn are Fourier coefficients. A naught, an, and bn are Fourier coefficients. Okay, and the value of the Fourier coefficient can be obtained with the help of this formula. A naught is 1 upon L integral c2 c plus 2l f of x dx. An can be calculated with the help of formula 1 upon L integral c2 c plus 2l f of x into cos of n pi x upon L dx, and Pn can be calculated with the help of formula 1 upon L integral c2 c plus 2l into f of x into sine of n pi x upon L dx. So this is also called the Euler's formula for the Fourier coefficient, and this formula can be derived from this Fourier series itself with the help of the formula which we have discussed in the last slide, like with the help of this formula. How it is? Like if I simply integrate this function throughout by integrating it within the given limit c to c plus 2l, then what is the integral of cosine in the limit c to c plus 2l? It is 0 because of the first property, right? Cosine and sine, both the integrals are 0. So basically we get integral of a naught in the limit c to c plus 2l. So from there we can get the value of a naught only. And to calculate the value of an, I multiply throughout with cosine function. Okay, so in that case we can use this property that when cos into cos is there, then its value is L when n is not equal to m, and is 0 when n is not equal to m. So there we can get only this term non-zero, rest all terms are 0, because integral, if we multiply it with cosine, then integral of cos is 0, sine into cos is also 0. So we can get f of x into cos. And similarly, to calculate the value of Pn, we can multiply this entire expression with sine m pi x upon L, you can say. And we can get the formula of Fourier coefficient Pn also. Okay, so these are the Fourier coefficients. So here we can get one more important thing. So because we have a property of integration, that integral minus a to a f of x dx, this is equal to 0 if f of x is equal to minus, if f of x is odd function. If f of x is odd function and its value is 2 times integral 0 to a f of x dx, if your function f of x is even function. Okay, so because here the interval is c to c plus 2l, so if our starting point is minus l, okay, if I replace c with minus l, so your interval c to c plus 2l, it can be reduced to minus l to l, right? So in that case we can use this property. So what will happen in that case? Let us consider in the next slide. So here we are going to consider that if your function f of x is defined in the interval minus L to L, then suppose we are considering case number one, if your function f of x is even, your function f of x is even, that is f of minus x is equal to f of x, then what is the value of a naught? A naught is 1 upon L integral minus L to L f of x dx. Now, because your function is an even function, so in case of even function, we can use the property here that minus L to L f of x dx. This is equal to 2 times 0 to L f of x dx if your function is even function. What is the meaning of even function? If a function satisfies this property, right? And if your function is odd, then minus L to L f of x dx is equal to 0, right? So in this case, this can be written as 2 upon L 0 to L f of x dx. What about the value of the Fourier coefficient an? An is 1 upon L integral minus L to L f of x into cos of n pi x upon L dx. Okay, so what is the even function? Even function is such that f of minus x is equal to f of x. So we know that cos of minus theta is equal to cos theta. So it means that cosine is a even function. And the product of two even function, let g of x is equal to f of x into cos of n pi x upon L. So what is g of minus x? This is equal to f of minus x into cos of n pi x L minus of x. But cos is an even function and f of x is also even. So f of minus x is f of x and cos of minus theta is cos of theta, right? So cos of n pi upon L minus x is cos of n pi x upon L. So this is nothing but equal to g of x only. Okay. So g of minus x is equal to g of x. So what does it mean? It means that the product of two even function is a even function. And if your function is a even function, then this can be written as 2 upon L 0 to L f of x into cos of n pi x upon L dx, right? And what about the value of the Fourier coefficient Bn in that case? So the value of Fourier coefficient Bn, this is equal to 1 upon L minus L to L f of x into sine of n pi x upon L dx. Now this time what will happen? Because we know that sine is an odd function. Because what is sine of minus theta? This is minus of sine theta. Okay, so sine is an odd function, but f of x is the even function. Okay, so product of even and odd function is, so let us consider h of x is equal to f of x into sine of n pi x upon L. So what is h of minus x? This is f of minus x into sine of n pi upon L into minus of x. F of minus of x is f of x because your function is a even function. But sine of minus theta is minus of sine theta. So here we get minus of sine n pi x upon L. So this is minus of f of x into sine of n pi x upon L. So it means that h of minus x is equal to minus of hx. So h of minus of x is equal to minus of hx. It means the product of even and odd function is odd. So if this function is odd, then according to this property, that if your function is odd, then minus L to L f of x dx is 0. So this integral is 0. So what will be the Fourier series? So it means that the Fourier series of the function f of x is given by f of x is equal to a naught by 2 plus summation n varies from 1 to infinity a n cos n pi x upon L. That is, in that case, the value of Bn is 0. And what is the value of Fourier coefficient A naught? A naught is 2 upon L, 0 to L f of x dx. And the value of the Fourier coefficient An is 2 upon L, 0 to L f of x into cos n pi x upon L dx. And obviously the value of Bn is 0. So this is the case if your function is defined in the interval minus L to L and your function is even function. If your function f of x is even function. Okay. So if your function f of x is even function and your function is defined in the interval minus L to L, then the Fourier series of the function reduced to a naught by 2 plus summation a n cos n pi x upon L. That is the value of Fourier coefficient Bn is 0. Now, what will happen if your function is odd? So let us consider case number 2. So if your function f of x is odd, odd means f of minus x is equal to minus of f of x. So in that case, what is the value of Fourier coefficient A naught? 1 by L minus L to L f of x dx. So because of the property of this integration, that if your function is odd, if your function is odd, then minus L to L f of x dx is 0. So this integral is directly 0. What about the Fourier coefficient an? This is also 1 upon L minus L to L f of x into cos of n pi x upon L dx. Now f of x is odd, cos is an even function. Okay, for example, I consider x into cos nx. So x is an odd function, cos is an even function, right? So suppose that this is your function. So what is f of minus x? This is minus x, but cos of n minus x. If I replace x with minus x, so cos of minus theta is cos theta. So it remains cos nx only. So the answer is minus of f of x. So it means that product of even and odd function, this is even function, this is odd function, is odd function. So it means that this integration is also 0. So what about Bn? Bn is 1 upon L minus L to L f of x into sine of n pi x upon L dx. Now what about f of x? F of x is odd, sine is also odd. So say x is the odd function, x is also odd function. Product of odd and odd is x square. X square is even function because if I replace x with minus x, so minus x into minus x is x square. So product of two odd function is even function, right? So because x square is an even function, because if I consider f of x as x square, then f of minus x is minus of x square is x square. Okay, so the product of two odd function is even function. So its answer is 2 upon L, 0 to L f of x into sine of n pi x upon L dx. So what do we conclude from here? If your function is odd, then the Fourier series, then the Fourier series of the function f of x is given by f of x equal to summation n varies from 1 to infinity bn into sine n pi x upon L. That is, in this case, the value of a naught and an, both of them are 0. So how do we calculate the value of bn? So here bn is calculated with the help of the formula. So bn can be calculated by bn equal to 2 upon L, 0 to L f of x into sine of n pi x upon L dx. Okay, so what we have discussed so far, let me conclude. So if your function is defined in the interval c to c plus 2n, that means if your interval is any interval, like it may be started from 0 to 2 pi, it may be like 1 to 5, it may be any interval. So in that case, the Fourier series of the function is given by a naught by 2 plus summation an cos n pi x upon L plus bn sin n pi x upon L. So what is L here? L is simply the half length of this interval. So what is the length of the interval? The length of the interval is upper limit minus lower limit, right? So basically what if so if your function is defined in the interval c to c plus 2n, right? So what is the length of the interval? The length of the interval is upper limit minus lower limit. So suppose your function f of x is defined in the interval c to c plus 2l, right? And what is the length of the interval? The length of the interval is upper limit c plus 2l minus lower limit, that is c. So c and c get cancel out, so its value is 2l. So we simply compare the length of the interval with 2l. So from there we can get the value of L. So this is the value of L which we are using in the formula of E naught, En and Bn. But if your interval is in the form of minus L to L, like minus 2 to 2, minus 1 to 1, minus pi to pi. So in that case, first step is we need to check either your function is even function or odd function. The condition of even function is f of minus x is equal to f of x. So if it is so, in that case, the Fourier series of the function is given by a naught by 2 plus summation an cos n pi exponent. That is the value of Fourier coefficient Bn is 0. And a naught and an, they can be calculated with the help of this formula. And if your function is odd, in that case, f of minus x is minus of f of x. And in that case, we need to calculate only one Fourier coefficient, that is Bn, because in that case, a naught and an, both of them are 0. And the value of the Fourier coefficient Bn can be calculated with the help of this formula, 2 upon L, 0 to L, f of x sine n pi x upon L dx. Okay, now let us try a problem so that we can understand the concept of Fourier series. So let us consider one example here. Okay, so the question is find the Fourier series of the function 2 to 4, sorry, interval is minus pi to pi. The function is discontinuous form. Like this is one of the condition of the Fourier series also. That in case of Dirichlet condition, we have discussed that a function has at most finite number of point of discontinuity in one of the period, right? Okay, so in this case, the given question, your function is piecewise continuous. It is a discontinuous at the point of minus pi as well as at the point pi. Okay, so it is defined in the interval minus pi to 0, it is 2, and 0 to pi, it is 4. So if we just look at the graph of the function, right? So this is minus pi to 0, and this is 0 to pi. It is given that from minus pi to 0, the value of the function is, say, somewhere here its value is 2, say here its value is 4. So from minus pi to 0, its value is 2, and from 0 to pi, its value is 4. So clearly this function is neither even nor odd because it is not symmetric about the ordinate axis, neither it is symmetric about origin, right? So if we calculate f of minus x, then its value remain 2, but your interval changes to 0 to pi, okay? Because if I replace here x equal to minus x, then its value is 0 to pi, and its value remain 4 in the interval 0 to pi. So its interval become minus pi to 0. Okay. So it means that this function is neither equal to minus of f of x nor equal to f of x because the interval is changed. So this function is neither even nor odd. So what will be the Fourier series in this case? So the Fourier series of the function, Fourier series is given by f of x equal to a naught by 2 plus summation an cos n pi x upon L plus Bn sin n pi x upon L. So what is the value of L here? L is the half length of the interval. So in this case, the length of the interval, that is 2L, equal to upper limit minus lower limit. So it is 2 pi. So what is the value of L here? L is pi. So if I replace L equal to pi, so it is a naught by 2 plus summation an cos nx, because pi and pi get cancelled out, and bn sin nx, again pi and pi get cancelled. Okay, so what is the formula of a naught? A naught is given by 1 upon L. So L is pi. So 1 upon L integral c to c plus 2L. So interval is minus pi to pi f of x dx. Okay, but because in this case your function is piecewise continuous. In the interval minus pi to 0, its value is different. In the interval 0 to pi, its value is different. So I'm going to split the interval into two parts: minus pi to 0 f of x dx plus 0 to pi f of x dx. So in the interval minus pi to 0, the value of the function is, in the interval minus pi to 0, its value is 2. So it is 2 dx. And in the interval 0 to pi, in the interval 0 to pi, the value of the function is 4. Its value is 4 dx. So on solving this integral, what do we get? 1 upon pi. 2 is constant. Integral of dx is x in the interval minus pi to 0. And 4 is constant. In the integral of dx is again x in the interval 0 to pi. So on solving this, so what do we get here? A naught equal to 1 upon pi. This is 2 times upper limit minus lower limit plus 4 times upper limit minus lower limit. This is 1 upon pi. This is 2 pi plus 4 pi. Answer is 6 pi upon pi. So answer is 6. So what is the value of the Fourier coefficient E naught? So E naught comes out to be 6. Okay. So because in this case your function is piecewise continuous. So to find out the value of the Fourier coefficient E naught, so I firstly split the integral in two parts, minus pi to 0, 0 to pi. Integrate this function, you can get the value. Now the next step is we need to calculate an. So what is an? 1 upon L c to c plus 2l, that is the interval, that is minus pi to pi, f of x into cos n pi x upon L, because L is pi, so we left with cos nx only. Okay. Again, we are going to split the integral as minus pi to 0 f of x into cos of nx dx and 0 to pi f of x into cos of nx dx. So this is equal to 1 upon pi integral minus pi to 0 minus pi to 0. The value of the function in the interval minus pi to 0 is 2. So it is 2 times, this is minus pi to 0, 2 times cos of nx dx, and in the interval 0 to pi the value of the function is 4. So it is 4 times cos of nx dx. So this is equal to 1 by pi. 2 is constant. Integral of cos nx is sine nx upon n in the interval minus pi to 0, and 4 is again constant taken outside. Integral of cos nx is sine nx upon n in the interval 0 to pi. So when we solve this integral, it is 1 upon pi 2 times upon n. When we substitute upper limit, it is sine of 0, because if x is 0, so n into 0 is 0, so its value is sine 0, minus lower limit sine of n into minus pi, so it is sine of minus n pi, plus 4 upon n, again substituting upper limit, this is sine of n pi minus sine of 0. So in this particular part, we are going to use one important property. The important property is that the value of sine function. So this is the important result which we need to remember, that the integral multiple of pi, the value of sine is always 0. That is sine pi, sine 2 pi, sine 3 pi is always 0. And cos n pi, its value is minus 1 raised to the power n. So this is the important result which we need to remember, which we use almost in many questions. We can use this particular result, right? So in this particular part, sine 0 is already 0, okay, and sine n pi is also 0, because sine of minus theta is equal to minus of sine theta, okay. So this negative sign become positive, but sine n pi is 0. So what do we get here? It is 2 upon n times 0 minus 0, and this is 4 upon n time, again sine n pi is 0, sine 0 is also 0. So the value of an comes out to be 0 only. Okay, so what do we get here? Value of an is 0. Now next, we need to calculate the value of Fourier coefficient Bn. So what is Bn? 1 upon L, that is pi, minus L to L, that is minus pi to pi f of x into sine n pi x upon L. So because already n and pi and L get cancelled out, so we left with sine nx only, right? So if I split this integral as 1 upon pi integral minus pi to 0 f of x into sine nx dx plus 0 to pi f of x into sine of nx dx. So the value in the interval minus pi to 0 is 2. So this is 1 upon pi minus pi to 0. It is 2 times sine of nx dx, and in the interval 0 to pi its value is 4. So 4 times sine of nx dx. So 1 upon pi, this 2 is taken outside. Integral of sine nx. So integral of sine ax dx is minus of cos ax upon a plus c in case of indefinite integral, but because it is a definite integral, so we are not using this arbitrary constant c. It is minus cos nx upon n, and this is 4 times minus cos nx upon n with the interval 0 to pi, and here interval is minus pi to 0. So on substituting upper limit and lower limit, 1 upon pi minus 2 upon n is constant taken outside. Upper limit, this is cos 0. Lower limit, cos of n pi, because cos of minus theta is cos theta, right? So minus n pi become cos n pi only, right? And the other integral part is minus 4 upon n common. On substituting upper limit, this is cos n pi. Lower limit, this is cos 0. Okay. So now, because cos even multiple of pi, cos 2 pi is 1, and same as cos 0, because cos is a periodic function with period 2 pi. So cos 0 and cos 2 pi is 1, its value is 1 only. So if we substitute this limit here, so we can get 1 upon pi minus 2 upon n, 1 minus 1 raised to power n, this is the value of cos n pi, and minus 4 upon n, again this is minus 1 raised to power n minus 1. So if we solve this particular part, so I can take negative sign common from here. So this is 4 upon n, this is minus 2 upon n. So if I take negative sign common, so it become negative, this become positive. So 1 minus minus 1 raised to power n. So plus 4 minus 2 is 2. So 2 upon n, 1 minus minus 1 raised to power n. So this is the value of Bn. So what is the value of Bn? This is equal to 2 upon n pi, 2 upon n pi, 1 minus minus 1 raised to the power n. So from here, what do you get the Fourier series as? So the Fourier series of the function is given as a naught by 2 plus summation n varies from 1 to infinity an cos nx plus bn sin nx. So we have calculated the value of Fourier coefficient a naught. It comes out to be 6, an comes out to be 0, and bn comes out to be this one. So if we substitute here, a naught is 6, so 6 by 2, an is 0, so 0 into cos nx, and bn is 2 upon n pi 1 minus minus 1 raised to power n times sine nx, or this is 3 plus this term is 0. So because this term is 0, so this whole term is 0. So we left with n varies from 1 to infinity. 2 upon pi is constant taken outside. 1 minus minus 1 raised to power n upon n times sine nx. Okay, so if I open this particular series, then we can get its value as 3 plus 2 upon pi. 3 plus 2 upon pi. So when I put n equal to 1, n is an odd number. So 1 plus 1 is 2 upon n sine x. So 2 upon 1 sine x. But when I put n equal to 2, that is even number. So we know that minus 1 raised to the power even number is always equal to 1, and minus 1 raised to the power odd number, its value is minus 1. So for odd value of n, its value is 2, and for even value it is 0, right? So it means that for n equal to 2 it is 0, for n equal to 3 it is again 2 upon 3 sine 3x. Then when I put 4, again it is 0, and when I put 5, 2 upon 5 sine 5x. Okay, and then when we put 6, again 0, then 2 upon 6 sine 6x, and so on. So it means that what is the Fourier series here? So we can get Fourier series as f of x equal to 3 plus 4 upon pi. That is 2 is more common. So sine x plus sine 3x upon 3 plus sine 5x upon 5, and so on. So this is the Fourier series of this function. Okay, so this is how we can find out the Fourier series of the function. So this is the simple problem we have considered, where the function is constant and it is defined in the interval minus pi to pi. So in that case, although the interval is minus pi to pi, but your function is neither even function nor odd function, so we need to calculate all the three Fourier coefficient in this case, right? So we have simply firstly calculated the length of the interval, then using the formula of A naught, An and Bn, we can calculate the Fourier series. Okay. So one important observation which we have in case of Fourier series that I want to discuss, let me write here. So important observation is that we need to use only two integration formula. Okay, that is either we should know the integral of sine ax. What is the integral of sine ax? That is minus of cos ax upon a. Apart from this, we also need the integral of cos ax, that is it is equal to sine ax upon a plus c. And apart from this, we also need the integral of x power n dx, that is x power n plus 1 upon n plus 1. And we also need the derivative of x power n power x power n minus 1. And there is one important formula, because if you have seen the formula of Fourier coefficient, that is A naught, An and Bn. So we have seen that while calculating the value of Fourier coefficient An and Bn, we need to take the product of the function with the sine function or the function with sine function. Okay. So we are going to use one important formula in the case of Fourier series, the product rule u into v, where this is a special kind of product rule where u is if u is the algebraic function of the type x power n, where n is a positive integer. Okay, and v is sine ax, cos ax, or exponential function. Okay, so this is a special product rule which we are going to use in the topic Fourier series only. Okay, so what is the condition in this case? Product rule. Your first function is the algebraic function of the type x power n, where n is a positive integer. And beside this, we have either sine, cosine, or exponential function. So what is the formula of this integration? It is u v1, that is first function. v1 stands for integral of v1 minus u dash v2 plus u double dash v3 minus u triple dash v4 and so on. So what is the meaning here? Here u dash represent derivative of u dash is the derivative of u double dash is the derivative of u dash, and u triple dash is equal to the derivative of u double dash and so on. And what is v1? Here v1 is integral of v2 is integral of v1, v3 is integral of v2 and so on. Okay, so how can we use this particular formula? Let us take an example. Suppose use the algebraic function of the type x square, and beside this we have a cos 2x. So how we are going to use this product rule? I'm assuming this x square as your u and cos 2x as your v. So what kind of product rule we are going to use here? So u is x square, v1. v1 is integral of cos 2x. So what is the integral of cos? It is sine ax upon a. So integral of cos 2x is sine 2x upon 2 minus u dash. What is the derivative of x square? This is 2x into integral of what is v2? v2 is the integral of v1. What is the integral of sine 2x? Minus cos 2x upon 2. 1, 2 is already there, so it is 2 square. Okay, again, what is the derivative of 2x? Because what is u? Then u dash is derivative of u double dash is derivative of u dash. So derivative of 2x is 2, and the integral of what is v3? v3 is the integral of v2. So integral of minus cos 2x is minus sine 2x upon 2 cube, right? And if we further integrate, what is the derivative of 2? So derivative of 2 is 0. So it means that we stop our integration process here. So what is the answer? Answer is x square by 2 sine 2x plus x by 2 cos 2x minus 1 by 4 sine 2x. That's it. This is the formula of this integration. Okay. So with the help of this integration formula, you can solve the integration problem very easily. So in the Fourier series, most of the problem we are having algebraic function of the type x power n. So with the help of this formula, you can easily solve the product rule, that is especially for a naught, an and bn. You can use this formula to evaluate the integral very easily. Okay. Let us try one more problem. We'll try to use this formula there. Okay, so now let us look at this function. Your function is x square in the interval minus pi to 0, and your function is minus x square in the interval 0 to pi. So if you just look at this function, what kind of this function is? F of x equal to x square, it is a parabola basically. In the interval minus pi to 0, it is upward parabola, right? So this is the kind of a graph it is. And in the interval 0 to pi, it is minus x square. Minus x square means it is a downward parabola. Okay, so you can easily identify that it is symmetric about origin. So in this case, your function is a odd function. Okay, So how do we identify what is f of minus x? F of minus x means minus x square in the interval minus pi is less than minus of x is less than 0, and its value is minus of minus x square in the interval 0 to minus x to pi. So this is equal to minus x square is x square, but because when we adjust this negative sign, the sign of inequality will change. Your interval will be 0 to pi, and this is minus x square. Again, if I multiply minus sign to adjust this negative sign here, your interval change to minus pi to 0. So what do we get here? In the interval minus pi to 0, earlier your function is xk, but now it is minus xk. And 0 to pi it is minus xk, so it is xk. So we can get here this is minus of f of x. So f of minus x is minus of f of x. It means your function f of x is odd function. In this case, your function is a odd function. So because your function is odd, and we have discussed here that if your function is an odd function, if your function is even function, then we get the cosine series. That means in that case we get a naught and an, right? So in that case we get cosine series. And if your function is an odd function, in that case your Fourier coefficient a naught and an, both of them are 0. So in that case we can get sine series. Okay. So where the Fourier coefficient Bn is given by this formula. So what does it mean? Because your function is odd function. So in this case, the Fourier series is given by f of x is equal to summation n varies from 1 to infinity Bn sine of n pi x upon L. That is the value of Fourier coefficient a naught and an. Both of them are 0. And again, in this case, if we just look at the length of the interval, that is 2L, is equal to upper limit minus lower limit. So its value is 2 pi. So here the value of L is pi. So if I replace here L equal to pi, then this pi and pi get cancelled out. So, and what is the formula of Bn? It is 2 upon L. L is pi, 0 to L, that is 0 to pi, f of x into sine nx dx. Okay. So because in this case a naught and an both of them are 0, we need to calculate only bn, and this is the formula bn here. And in the interval minus pi to 0, what is the value of the function? Minus x square. Although your function is discontinuous, but because in this case we need to evaluate integral in the limit 0 to pi only, and in the interval 0 to pi your function is minus x square. So I need to evaluate this integral as 2 upon pi 0 to pi. Your function is minus x square into sine of nx dx. Okay, so let us calculate the value of bn here. So bn is equal to negative sign taken outside minus 2 upon pi 0 to pi x square into sine of nx dx. So here again we are going to use the same formula of integration which we have discussed in the last slide, that we are using the product rule u into v. So u is the algebraic function, v is the trigonometric sine, cosine or exponential function only. So the formula is u v1 minus u dash v2, u double dash v3 and so on. So this is your u, this is your u and this is your v. So what is the product rule? Let me remind you, u into v dx. The formula is u v1, u dash v2, u double dash v3, u triple dash v4 and so on. Alternate sign, we have to take the derivative of u only, and we need to integrate v1, v2, v3, v4 only. Okay, so it is minus 2 by pi. So firstly, u means x square. V1, what is V1? V1 is integral of V. So what is the integral of sine? Like I told you, integral of sine AX is minus of cos AX upon A. So integral of sine nx is minus cos nx upon n minus. Now further, v dash derivative of x square is 2x. Further v2. What is v2? V2 is integral of v1 dx. So integral of minus cos is minus sine nx upon n square, because one n is already there. So here we are using n square, right? Next is u double dash. U double dash means derivative of 2x. Derivative of 2x is 2, and v3 is integral of v2. Integral of v2. What is v3? It is integral of v2. So v2 is minus sign. Integral of minus sign is plus cos nx upon n cube. Further derivative of 2 is 0. So it means that we stop our integration process here with the limit 0 to pi. So this is minus 2 upon pi, minus 1 upon n is common. Now substituting upper limit and lower limit. So firstly upper limit. X is pi, so it is pi square cos n pi. This is on substituting upper limit minus lower limit. X is 0, so its value is 0. Then in the second term, this negative sign become positive. So 2 upon n square is common. So what we have inside the integral? X, when x is pi, so it is pi into sine n pi minus, when we put 0, so 0 into sine 0 is 0. Come to the last term. Last term is 2 upon n cube. 2 upon n cube. Again, let it start. So on substituting upper limit, cos n pi minus cos 0. So now on solving this part again, like we have discussed the identity, that in this part cos n pi, cos integral multiple of its value is minus 1 raised to the power n, and sine integral multiple of pi, its value is 0. So if we use this formula here, then its value is minus 2 upon pi minus pi square upon n. Cos n pi is minus 1 raised to the power n, and sine n pi is 0. So it means that this term is 0. Okay, so this term is 0, and here we left with the next term is 2 upon n cube into cos n pi minus 1 raised to power n. Cos 0 is 1. So this is basically the part of, this is the second step. So minus 1. So this is the value of the Fourier coefficient Bn. So Bn is known. So what is the Fourier series? So Fourier series f of x is given by summation n varies from 1 to infinity Bn sine of nx. So this is equal to summation n varies from 1 to infinity. The value of Bn comes out to be minus pi square upon n minus 2 upon n. So minus 2 upon n into minus 2 upon pi times minus pi square upon n into minus 1 raised to the power n plus minus 1 raised to power n minus 1 upon, okay, so this 2 upon pi is multiplied with the entire expression. So 2 upon n cube minus 1 raised to power n minus 1 time sine of nx. So this is the Fourier series of the function f of x. Okay, so if we expand this particular series, again, for this particular term, if n is even, then this term is 0. If n is odd, we can get minus 2. But this particular term is defined for even as well as odd because it is simply minus 1 raised to power n, or I can write minus 1 raised to power n plus 1. Okay, so you can get this particular value of the Fourier coefficient Bn in this case. So what we have seen here, your function is again defined in the interval minus pi to pi. So first step is we need to check the nature of the function. So here we realize that your function is an odd function. So in case of odd function, the Fourier series of the function is sine series only. That means in this case, the value of Fourier coefficient A naught and En, both of them are 0. And the value of the Fourier coefficient is given by 2 upon L, 0 to L, f of x sine n pi x upon L, where L is the half length of the interval. So using the formula of this integration product rule, we can get the value of Fourier coefficient Bn. Substituting the value of the Fourier coefficient Bn in this series, we can get the Fourier series of the function. Okay, let us try the another function. So here your function f of x is minus of pi plus x in the interval minus pi to 0, minus of pi of minus x in the interval 0 to pi. Again, your interval is minus pi to pi. So the first step is we need to check that what kind of this function is. So like if I open this bracket, this is minus pi minus x in the interval minus pi to 0. And if I open here, it is minus pi plus x in the interval 0 to pi. So minus pi is a constant function. So in the interval minus pi to 0, its value is minus x. In the interval 0 to pi, its value is plus x. So basically, this is like a mod x function, minus pi plus mod of x, right? So because if x is negative, then mod of x is minus x, right? Well, how mod x function is defined? Its value is minus x if x is less than 0, and its value is x if x is greater than or equal to 0. Okay, let us realize, check here. So if I replace x with minus x, so minus of pi minus x in the interval minus pi to 0, and here it is minus pi plus x in the interval 0 to pi. So if I multiply negative sign for this part, so it is minus of pi minus x in the interval 0 to pi, and its value is minus of pi plus x in the interval minus pi to 0, right? So you can see here, so in the interval minus pi to 0, pi plus x. In the interval 0 to pi, it is pi minus x. So it means that this function is a even function. So it means that this function is an even function. And in case of even function, the Fourier series is given by, in case of even function, the Fourier series is given by f of x equal to a naught by 2 plus summation an cos n pi x upon L. That is, in this case, the value of Fourier coefficient Bn is 0. And again, in this case, your interval is minus pi to pi. So the length of the interval is 2 pi, that is L is pi. If L is pi, so it means it is cos nx. So we need to calculate, this time we need to calculate Fourier coefficient A naught and An only. So what is the formula of A naught? It is 2 upon L, that is 2 upon pi, 0 to pi, f of x dx. So again, although your function is piecewise continuous, But because we need to integrate our function in the interval 0 to pi only, and in the interval 0 to pi, its value is minus of pi minus x. So I can integrate it minus of pi minus x dx. So it is simply polynomial function, or like I told you, then in the Fourier series, in most of the problem, we need to use only three formulas, right? Integral of polynomial function, derivative of polynomial function, or integral of sine and cosine function. These are the formulas we require for solving this integration. So minus 2 upon pi common. If we separate the term, then this is integral of pi is pi x, integral of x is x squared by 2 in the interval 0 to pi. So from here, we can get the value of a naught as minus of 2 upon pi x minus x squared by 2 in the interval 0 to pi. So on substituting upper limit, pi time pi minus lower limit is 0, and here 1 by 2 common, upper limit x will become pi, it is pi square, x is 0 becomes 0. So it means that a naught equal to minus 2 upon pi, inside bracket this is pi square minus pi square by 2. So its value is pi square by 2. So 2 and 2 get cancelled out, 1 pi get cancelled out. So its value is minus pi. So what is the value of a naught? Minus pi. Okay. So this is the value of a naught. Next, we need to calculate the value of an. So the formula of an is 2 upon pi 0 to pi f of x into cos of nx. Because in this formula, we are using L equal to pi only. So 2 upon pi 0 to pi, the function is minus of pi minus x. In the interval 0 to pi, its value is minus of pi minus x into cos of nx into cos of nx dx. So again here we are using the product rule u and v. So this time we are assuming this is your u, this is your v. This minus sign can be taken outside. So minus 2 upon pi. So what is the formula? U, that is pi minus x, v1. v1 means integral of v. Integral of cos is sine of nx upon n minus derivative of pi minus x is minus 1. U dash is minus 1. Now v2 is integral of v1. Integral of sine is minus cos nx upon n square. And further derivative minus 1 is 0. So it means we stop our integration process here. So we simply need to substitute upper limit and lower limit. So here this negative sign cancel out. So now on substituting upper limit and lower limit. So on substituting upper limit, pi minus pi, it is 0. And on substituting lower limit, this is pi minus 0 into sine 0. So sine 0 is also 0. Okay, so it means that basically this term is also 0 only. And here minus. So 1 upon n square is common. On substituting upper limit, this is cos n pi. And when we substitute lower limit, it is cos 0. And cos 0 is 1. So we can get here minus 2 upon pi into minus 1 upon n square into minus 1 raised to power n minus 1, because this whole term is 0. So this negative sign get cancelled out with this. So the value of an, it is equal to 2 upon pi n square minus 1 raised to power n minus 1. So a naught and an, they are known to us. So we can get the value of Fourier series. What is the Fourier series here? So the Fourier series of the function is a naught by 2 plus summation an cos nx. So the value of an is minus pi. So this is minus pi by 2, and the value of an is 2 upon pi n square minus 1 raised to power n minus 1 into cos of nx. Okay, and even if we expand this, if we open this bracket, then 2 upon pi is constant. If I put n again, minus 1 raised to power n minus 1. Okay, let me write it separately. Okay, so minus 1 raised to the power n minus 1. If n is even, and for even number, its value is 0. And if n is odd, minus 1 raised to power n minus 1 is minus 2 if n is odd, right? Because n is 1, its value is minus 1, minus 1, minus 2. If n is 3, minus 1 is minus 2, and so on. And if n is even, 2 minus 1 square is 1. So 1 minus 1 is 0. If I put any even value of n, its value is 0. Okay. So basically, if I open here, we get 1 upon 1 square into minus 2 cos x plus 1 upon 3 square minus 2 cos 3x plus 1 upon 5 square into minus 2 cos 5x and so on. So in other words, I can write f of x equal to minus pi by 2 minus 2 upon pi. So 1 upon 1 square cos x plus 1 upon 3 square cos 3x plus 1 upon 5 square cos 5x and so on. So this is the Fourier series of the function f of x, which is basically the cosine series. Okay. One more important point here we have. So with the help of Fourier series, we can also calculate the value of the infinite series. Like if you see here, if we simply remove cosine function from here, okay, so in that case, we are getting an infinite series of the form 1 upon 1 square plus 1 upon 3 square plus 1 upon 5 square and so on, right? So it means that we can calculate the value of the infinite series. So how can we remove this? So because our function is defined in the interval minus pi to pi. So if I put x equal to 0, cos 0 is 1. So cos 0 is 1. Okay. So if I put x equal to 0, put x equal to 0. So we get f of 0 equal to pi by 2 minus 2 upon pi. Here we get 1 upon 1 square, 1 upon 3 square, 1 upon 5 square, and so on. Okay. So if we just look at here, your function is defined when x equal to 0, this is the value, means its value is minus pi. Okay, because your function is defined at the point x equal to 0. So when I put x equal to 0, its value is minus pi. So f of 0 is minus pi. So minus pi, if I take pi by 2 this side, this is minus pi by 2. Its value is minus 2 upon pi, 1 upon 1 square, 1 upon 3 square, 1 upon 5 square, and so on. So it means its value comes out to be minus 3 pi by 2 equal to minus pi by 2. Sorry, minus 2 by pi. Minus 2 by pi. Okay, basically, if I take 2 common, it is minus 4. It is not 2, it is basically 4. Because 2 is already there, minus 2 I have taken common in all the term. So it is minus 4 by 5. So its value is minus 4 by 5. So minus 4 by 5 times 1 upon 1 square, 1 upon 3 square, 1 upon 5 square, and so on. So we can get here, this negative sign get cancelled out. If we take this factor on the other side, this is 3 pi by 2 into 4 into pi equal to 1 upon 1 square plus 1 upon 3 square and so on. So the value comes out to be 3 pi square by 8. Okay, is it so? Mm-mm. Its value is minus pi by 2. So when we take this side, it is minus pi by 2. Let me correct this. So its value is pi square by 8. The value of this infinite series comes out to be pi square by 8. So what do we get here? That summation, if I want to write this expression in a compact form, then I can also rewrite it as summation 1 upon 2n minus 1 whole square. This is equal to pi square by 8, where n varies from 1 to infinity. Okay. So it means that with the help of the Fourier series, we can not only express our function in the form of sine and cosine series, we can also calculate the value of some infinite series with the help of this particular expression. Okay. So here we have taken some example of the Fourier series where we can express our function in the form of Fourier series. Okay. So I'll try to continue this particular part to discuss some other type of the problems also based on Fourier series, and of course the next topic is half range Fourier sine and cosine series in the next part. Okay. So for the time being, you just revise this particular topic. If you have any doubt or any query related to this part, you can post your query. Okay. So till then, thank you.